Hey guys, in this video we're going to be taking a look at how to work out the equation of straight lines. So there's going to be no funny business in this video, no fractional gradients or anything silly like that. We're just going to be looking at the how of finding equations of straight lines. We can do trickier things in videos to come. So first of all, make yourself aware of the general equation of straight lines. Y equals mx plus c. So m is the gradient and c is the y-intercept. So remember that to find the gradient, we find the difference in our y values and then divide that by the difference in our x values, which we can think of as dy over dx. If the gradient is at all shaky, check out my video on that. We've got a 10-minute video all about finding gradients. It's really exciting. So if you find the gradient parts of this video tricky, be sure to check out that video. So we get asked three main types of questions to do with finding equations of straight lines, really. So type 1, we'll be given an equation of some line and a single coordinate point, and we'll be asked to find a parallel line that passes through that point. We might be given a line drawn on a graph and asked to work out its equation, or we might be given two sets of coordinates and we'll be asked to find the equation of the line that connects those 2 points together. So we're going to look at three examples of each. Let's get going. So example 1. Find the equation of the line parallel to y equals 3x add 2 that passes through the point 8, 12. So if two lines are parallel, it means they have exactly the same gradient. So the only important bit of information from y equals 3x add 2 is the 3. So that tells us then if our line is parallel to 3x add 2, then it's something to do with y equals 3x and then add the c on the end. So there's an infinite number of lines parallel to y equals 3x add 2. An equation with a 3x in it is parallel. So what we need to do, we need to work out the value of c. There is only one parallel line that crosses through the point 8, 12. So to work out c, we use the coordinates. So remember what coordinates are telling us. They're telling us the values of x and y at a given point on this line that we're looking for. So when x is equal to 8, y is equal to 12. So we substitute those values into this equation. So y is 12, so we get 12 is equal to, now x is 8, so 12 is equal to 3 times 8 plus c. That will give us 12 is equal to 24 plus c. Now take away the 24, we get minus 12 is equal to c. So we've worked out the value of c. So our equation is y equals 3x minus 12. Jobs are good. Okay, example 2. Find the equation of the line parallel to y equals 7x minus 9 that passes through the point minus 1, minus 1. So again, the only important part of information from the equation we're given is the gradient, 7. So that tells us then the guy we're looking for is something to do y equals 7x plus c. So now we need to find the value of c. So again we use the coordinates, x equals minus 1 and y is equal to minus 1. So we get minus 1 equals 7 times minus 1 plus c. Minus 1 equals minus 7 plus c. And then finally add the 7 to both sides. Minus 1 at 7 will give us 6 is equal to c. So the equation of our line is y equals 7x add 6. Cracking, jobs are good. Okay, let's look at one more example like that. So find the equation of the line parallel to y equals minus 10x add 5 that passes through the point 0, 0. So again, the only important part of information in that equation is its gradient, and that tells us our guy is something to do with y equals minus 10x plus c. Now we need to find the value of c. So x is equal to 0 and y is equal to 0. That's actually just going to leave us with 0 is equal to minus 10 times 0 plus c. That's going to leave us with 0 equals c, because minus 10 times 0 is 0. So the equation of this line is actually just y equals minus 10x. Okay, so that's how we attack questions like that. Let's look at it on a graph. Okay then, so the next 3 questions we're going to be finding equation of lines on graphs like this chap here. So before we get cracking, what can we tell straight away from looking at it? Well, the line is going up from left to right. So that means we've got a positive gradient. Now if you're given a graph like this and you can see the y-axis, we can already write down the value of c. So let's just zoom in, because I know it's a bit microscopic. So we can see here that the line crosses the y-axis at 9. So that tells us then that the value of c is already equal to 9. So we can write down y equals mx plus 9. So remember, that's because c is the y-intercept. Now we can also use the y-intercept coordinates, in this case, as one of our pairs of coordinates that we can use to find the gradient. So what we also need to find is another point that has nice integer coordinates. So for example, this point here, the line crosses exactly through the corner of a square, and then we can see that his coordinates will be minus 2, 5. Okay, so once we've got 2 pairs of coordinates, we can then go ahead and work out the gradient. So the gradient is equal to the difference in your y values. So here I'm going to do 9 take away 5 over the difference in your x values. So 0 minus 2. That's going to give me 4 divided by positive 2, because 0 minus minus 2 is positive 2, and then 4 divided by 2 is 2. So the equation of my line here is y equals 2x add 9. Cracking. Okay, example 5. So with this one, we now can't see where the line is crossing the y-axis, so we can't just write down the value of c. What we can see though is that it's going to be below the x-axis, so we do know it's going to be negative. And we can also see that the line here is going down from left to right, so we're going to be dealing with a negative gradient. So what we need to do, we need to find 2 nice integer coordinates. So we've got this guy down here, and we've got this guy up here. So let's zoom in so you can see those coordinates. So this one is minus 1, 2. And then this chap up here is 1 to the left, so it's going to be minus 2. And then the y coordinate is 10. So our coordinates here then are minus 2, 10. So what we do in a situation like this where we can't write down the y, intercept from the get-go, we need to first of all find the gradient. So remember, we're playing with y equals mx plus c. We need to find m first of all. So here I'm going to do 10 take away 2 over minus 2 minus 1. Now 10 take away 2 is probably 8, and then minus 2 minus 1 is going to be minus 2 add 1, which is minus 1, and then 8 divided by minus 1 is minus 8. So we can fill in the gradient now of our line y equals minus 8x add c. So now we need to find the value of c. To do that, we use one of our pairs of coordinates, either minus 1, 2 or minus 2, 10. I would always use the smaller of the two. So here I'm going to use minus 1, 2. So remember, that's telling me that when x equals minus 1, y is equal to 2. So we substitute those in. 2 equals minus 8 times minus 1 add c. 2 is equal to, or minus 8 times minus 1 is positive 8 plus c. If we take away that 8 on both sides, we will be left with minus 6 equals c. So the equation of our line here is y equals minus 8x minus 6. Cracking, jobs are good in. Okay, example 6. So what can we see about this graph? Well, we can see that it's got a positive gradient because it's going up from left to right. And this time we can see where it crosses the y-axis, so that's nice. So, first of all then, let's get the value of the y-intercept, which is 1. So that tells us then that c is equal to 1, and our equation is of the form y equals mx plus 1. Now we're also going to steal that coordinate to use as one of our two sets. So the coordinates of the y-intercept here are 0, 1. Cracking. So let's find another nice whole integer set of coordinates. We've got this chap right here. Now the coordinates of this guy are going to be 1, 6. So let's also write that down. Okay, so now what we need to do is find the value of the gradient. So m is going to equal, now here I'm going to do 6 take away 1 over 1 take away 0. That's just going to leave me with 6 take away 1 is 5 divided by 1, which is 5. So the equation of our line for this chap is y equals 5x add 1. Cracking. So that's how we find equations of lines when we've got the graph. Now we're going to be looking at finding the equations from two sets of coordinates. So, find the equation of the line connecting 1, 6 and 10, 42. So, with a question like this, we always need to find the gradient first. So, m is equal to, let's say, 42 take away 6, the difference of the y values, over 10 take away 1. So up on top, 42 take away 6 is going to give us 36. And then on the bottom, 10 take away 1 is 9. 36 divided by 9 is 4. So m is 4. Our equation is of the form y equals 4x add c. And now we need to find the value of c, so we use one of the pairs of coordinates. Again, I would always use the smaller of the two. So here I'm going to use 1, 6. So remember, that's telling me when x is equal to 1, y is equal to 6. So if we substitute those in, we get 6 is equal to Well, 4 times 1 is 4 plus c. And then we need to take away that 4 on both sides. So 6 take away 4 is 2. So that would tell us then that c is equal to 2. So the equation of our line here is y equals 4x add 2. Jobs are good. Now you can check these answers. Check this against our coordinates here. So does this work with 1, 6? Well, 4 times 1 is 4, add 2 is 6. Cracking. 4 times 10 is 40, add 2 is 42. Cracking. Jobs are good. Okay, example 8. Find the equation of the line connecting 0, 0 and 10 minus 20. So, again, we need to find the gradient first of all. So, m. Now here I'm going to do minus 20 minus 0, the difference in our y values, divided by 10 minus 0. Now minus 20 minus 0 is minus 20, 10 minus 0 is 10, and minus 20 divided by 10 is minus 2. So our equation is of the form y equals minus 2x plus c. Cracking. Now we need to find the value of c. So we substitute in one of our sets of coordinates. Now here there is definitely a simpler one, the 0, 0. That's telling us when x is equal to 0, y is equal to 0. So we would get 0 equals minus 2 times 0 plus c, which would lead us to c equals 0. So the equation of our line here is just y equals minus 2x. Now again, if we check that against our coordinates, when x is 0, y is supposed to be 0. So y is equal to minus 2 times 0. Yes, that is indeed 0. When x is 10, y needs to be minus 20. So y would equal minus 2 times 10, which is indeed minus 20. Jobs are good in. And then the 9th and final example for this video. Find the equation of the line connecting minus 7, 8 and 10 minus 9. So y equals mx plus c. Hopefully by now you're happy that we need to find the value of m first. So m then is going to equal, now whichever way around we do this, we're going to get a negative answer, so we can't avoid negative numbers, sadly. So I guess I would probably go for 8 minus 9 up on top. And then we have to do minus 7 minus 10 on the bottom. So up on top, 8 minus 9 is going to give us positive 17, because we've got that double negative. And then on the bottom, minus 7 minus 10 is minus 17. So 17 divided by minus 17 is minus 1. So that tells us our equation is of the form y equals minus x plus c. Okay, so now we substitute in one of the sets of coordinates. So I'm going to use minus 7 and 8. So that tells us when x is minus 7, y is equal to 8. So we're going to get 8 is equal to minus 7. So we've got that minus x there. Add c. So we've got 8 equals positive 7 plus c. And then if we take that 7 away, that would tell us that c is equal to 1. So here the equation of our line is y equals minus x plus 1. Or we could write that as y equals 1 minus x. Completely up to you. So let's check that against our coordinates. So when x is minus 7, x is x needs to be positive 8. So if we substitute that into 1 minus x, 1 minus minus 7 is 1 plus 7, which is indeed positive 8. Let's check it for 10 minus 9. So when the x is equal to 10, y needs to be minus 9. So 1 minus 10 is indeed minus 9. Okay guys, that's an introduction on finding the equations of straight lines. Hope it's useful. Was this video helpful? If so, be sure to leave a thumbs up and a comment telling me how you get on. For any further information, you can follow me on Facebook and Twitter, and send requests or any feedback you have. Search for Maths with Mouth. Cheers guys.